Okay, so let's begin. I have two samples for you today, both of the same type. Zach, you'll remember there are 7 types of problems. This is type 7. Absolutely 100% rock solid guarantee. This question will be on the test. This question will be on the exam. Guaranteed. There's very few things in life that are as guaranteed as that.
How large is this question? Would it be almost a full page?
Oh yes, this is a page and a half, if not more.
Oh, shoot.
This is the 11-mark question on the exam. This is the pinnacle of kinematics knowledge as far as you go. Oh yes, you would be a fool not to write this down. Well, the numbers will be different, but basically it's this question. It'll be something that's launched at an angle off a cliff. Okay, so I'm going to give you time to jot that down while I do my tense, and then we'll begin.
The big V is the velocity.
The big V stands for velocity, the small v stands for vertical. Okay, so here we have a ball, maybe it's a baseball, a golf ball, doesn't really matter, some sort of projectile. It's hit at 53.1 degrees, which is a really weird angle. I will explain why, and you will see shortly why 53.1 was chosen. Above the horizon, ATH, and has an initial velocity of 10 meters per second as shown. Find the vertical component, the horizontal component, the time of rise, the height of rise, the time of flight, the range, and the velocity of impact. 9 times out of 10, these things are not going to be asked in the question. I've just put them in here as a sample to sort of show you the steps that you're going to need, right? But the things that people are most interested in are range, which is how far away from the base of the cliff, and how fast is it going when it hits the ground. Those are the 2 things, right? But these are the steps to find that. It's always a good idea to find the component. So let's start with that. So the vertical component is going to be V sine theta. So that's going to be 10 sine 53.1.
It's always sine?
Yeah. Pretty much. The reason it's sine is because, right, this would be VV and this would be VH, and 9 times out of 10 you're given that angle there because it's above the horizon. The only time it would be cosine would be if you'd be given this angle here, which would be from vertical, which doesn't usually happen, unless you're silly like Evel Knievel and launching at like 89 degrees. So I won't say always, but I'll say most of the time. So this is going to be 10 times the sine of 53.1. And it works out to 8. And the reason that 53.1 was chosen is because it gives you a sine value of 0.8. Right? So it gives you a nice, round, even VV of 8. Horizontal component is going to be V cos theta 10 times the cosine of 53.1. Six. Both positive because one is up and one is to the right. Okay? 2 easy marks to get you started. Should you always find the components? Pretty much, right? If it's going to be at an angle, is there always going to be a component, vertical and horizontal? Yeah, absolutely. Okay. Time of rise. Now the reason that I pulled this in is because I want to bring about a conversation. So the time of rise is only that part there. For my sake, I'm just going to write down VV is equal to 8, and the VH was 6. You don't need to write that down again, I just can't see it, right?
Time of rise is like the highest.
How long it takes to go to that peak, the highest point. Now, at this point right here, I'm going to say VF is 0. It sure is, right, Jason? That's the vertical component is 0, right? The vertical component is 0. What, remember from before break, What maintains? Always the same? What's always the same? What value is all? Two things actually. Horizontal component remains the same. This 6 is constant, right? Right? There's no horizontal acceleration. It continues to travel through the air at 6 meters per second, straight forward. Doesn't give a rip what the BV is doing at all. Okay, so VF equals 0. What's the VI vertically? The VI is that 8. The VI is the 8 because we're talking about time of rise. This is a vertical question. We talk about the 8. Not the 10, that's the combined, not the 6, that's horizontal. So then it's going to be VF equals VI plus AT. What's the final velocity? 0. What's the initial for this? 8 plus minus 9.8 times t. And so t is 8 divided by 9.8. That 8 actually is negative, right? Goes to the other side. Well, let's deal with this one first. Don't get ahead of the game here. I get 0.82 seconds. How high it goes. How high it goes above the height of the cliff.
Oh, like, it's not like, at peak, how high is it?
Do we know how tall this cliff is?
400.
Oh, it's a little high.
What do you see that?
Way at the start. It's a little higher than I
Oh,
need to, yeah. Okay, so height of rise is only referring to that distance there, right? Do I know, I'm trying to find D, what's the VI? Can I use D equals VIT plus a half AT squared? I can, because I know the T, and I know the initial velocity.
This one would have to do with vertical again, right?
Again, height of rise, exactly, Steve, vertical. The only one that deals with the horizontal is which one? The range, exactly. That's the only one. So my D is equal to my initial vertical component, which is 8. Are you glad, as a grade 11 student, you were made to write the formulas out? Does it make sense now? Remember those easy questions, you know, guys running 200 meters in 12 seconds, what's the speed? 200 divided by 12. I don't need no stinking formula.
I think there's a kind of isn't a formula.
Well, I know, but people, the grade 11s, I don't need that formula. I just divide it, right? I just times it. They're stubborn, exactly. You got to do it. You got to show your work. You guys tell those grade 11s. Help me out. So it's 8 times t, 0.82, plus 1/2, minus 9.8. What's my t? 0.82 squared. There's no way you could do this question without writing it out. I get 3.27. 3.27 meters. Does it go very high? Hardly at all. How come it doesn't go very high?
It's the acceleration.
What is the angle? I can't remember. Well, the angle's at 53 degrees. It's pretty steep, but it's only got a vertical component of 8, right? And the time that it's actually rising is only less than a second. So it's not going to go very far. So it only goes 3.27 meters higher. Okay, here comes my favorite part. Total time of flight. Now, when we did the question with me, we did sample number 2, right? We did. Maybe we didn't. Did I do a sample question like this? where it was just, yeah,
Wasn't that the garbage can? We never actually did much.
we never, you know what? Yeah, because I had planned to do that, and then because, so, yeah, okay, that changes my entire timeline. Anyways, okay, well, I'll have to come back to that. I'll have to come back to sample number 2, because I'm not gonna stop now. When the ball, if you're like the center fielder and you throw the ball in from center field, right, and the ground is flat, is the time up equal to the time down?
Yes.
Absolutely. The time it takes to go up is exactly equal to the time to come down. The acceleration is the same, and the distance up is the distance down, everything's the same. But when you're on a cliff, and it goes like this, is the time up equal to the time down? No, how come? It's got a lot longer way to fall than up, right? It only goes up 3.27. How far is it falling? 403.27. It's got, I won't say a whole, no, it's got a whole lot farther. It's got 400 meters farther to go. So the time up is equal to the time down. The answer to that is an emphatic no. So you can't just take 0.82 seconds and add it on another 0.82 seconds. Right? Because that's what you would do here. Right? That time up is only there. This is the time down. Now, there are 2 ways to deal with this. There's the brute force way, and there's what I think of as the elegant, I'm smarter than the average Joe way. Question, Ryan?
Would you just like find walking distance then?
Absolutely. And we know that, right? The falling distance is minus 403.27, right? And what is the initial velocity for that interval? 0, because it's falling from that peak. And the acceleration is minus 9.8. And it would be relatively easy to do that. In fact, let's just do that. Good? It's just falling, right? That's why that vertical component is 0. So you're going to have here t equals the square root of minus 403.27 all over minus 4.9, right?
I don't know.
82.3. Yeah, how come? It's 400 meters in the air. That's assuming that it accelerates at that entire time too, and things don't. That 400 meters I need to change. I need to change it to 40. It's crazy long, but we'll just deal with it. Now, is that the total time? No, it's in fact 82.3 plus this number here, 0.82, right? So that's going to be 80, whoopsie. 82, oh no, it's 83, isn't it?
Yeah.
83.12, I think, if I'm not mistaken, right? Okay, so what were all the steps that we had to do to get that total time? I'll come back to this page here. Just give me a second here. I had to find the time of rise. Did I need to find the height of rise? To get to that next, yeah, I needed this, 0.82, and I needed this, right? And then I had to add that number onto 400, which I did in my head, but I still had to do it. And then I did this whole thing. So basically it's, oh, and then I had to add that on. It's basically 5 steps to get to there, right? I liken that to that's sort of the brute force, mechanical, man on the street kind of way to do it. Now, there's an easier way. It's the I'm smarter than the average bear, the more elegant, sort of sophisticated way I like to think of
You
it.
didn't square root your number there.
Oh, I didn't.
Oh no.
It's 9.07.
That makes more sense. You know what? I've been doing that lately for some reason. I forget to do that. Thank you, Jason. What is the number?
9.07.
Okay, that's a little more reasonable, right? It did seem awfully big, and I just sort of glossed over it. What should I take off if you do that on a test again? If that. If I'm feeling in a particularly generous mood, I might not even take anything, because I've made that mistake lots too. Is that crazy talk? So it's going to be 9.89 seconds. No, there's on occasion. If it's nice and neat and all laid out, that's the only tiniest mistake you made. Yeah, a little dig there.
I guess I'm not okay.
Guess you're out, okay.
No, I guess I get the right answers anyways.
Oh, shots fired. At what angle? Alright, so anyways, 5 steps. Are you feeling particularly elegant, a mathematical sophistication?
Do you have to have a timer to this question?
Maybe a monocle, like the Monopoly guy? Okay, here's what I want you to think about. D equals VIT plus 1/2 AT squared. For the entire trip, what is the displacement?
406?
No, the displacement for the entire trip. You start at the top of this 400-meter high cliff and you go minus 400. Right? You start from a level, you go up, but who cares? Your overall displacement is minus 400. Okay?
Why don't you keep it go up, but that's still a distance.
It's not displacement.
But it's not displacement, that's right.
What's the distance, difference from distance?
Distance is how far you travel, right? Now, having said that, this is actually displacement here. It's minus 403, but that's from the top, right? We use this because we want the VI to be 0. But we can't do that here. If we say the D is minus 400, then the VI is actually 8. And not only 8, but it's plus 8. Let me lay it all out, and then I'll explain, okay? Plus 1/2, what's my acceleration? And I'm solving for T. Do you have that sinking feeling in your stomach? Do you know what's coming?
I don't know. No.
Doing it again, but we're doing it
No.
the sophisticated way.
I don't know.
So is this just a different way of finding the same answer?
Same answer, single step.
Define the answer for all of those.
Those 5 steps, single
I
step.
don't even write that. I didn't know.
So what did I do here? I said the displacement is minus 400. My initial vertical velocity is plus 8 because it goes up. My acceleration is minus 9.8 because it's down. Does it have to be negative 9.8? This is one of those instances where it absolutely, positively must be. Does this have to be plus 8? Yeah, it's going to change the answer, right? Like if I fired it straight down at 8, it would matter. Okay, and yes, I've ended up with a quadratic equation
So why is it positive?
because it's up.
Because
Positive 8 because it's up.
oh, that's you're launching it up.
Launching it up.
Okay.
Okay, so now quadratic formula, x equals, and I would encourage you to write out the quadratic formula. I always do, and I've been doing it for a long time. Okay, I don't have to look up the quadratic formula because I've written it out a gazillion times and I just know it. It's one of those things that ask me when I'm 80, I may not remember my name or my birthday, but I'll know the quadratic formula. It's Tx. Right? So x equals minus b. B is the 8. Minus 8 plus or minus square root b squared. 8 squared minus 4. The a is the minus 4.9. And yes, you have to be extremely careful with your negative signs here. Then times c. 400 all over 2 times A right? What happens if the square root is a negative, like the number under the square root? Can't be solved, right? Is that going to happen? Is that possible here? No, it's going to have to be, right? There's going to have to be a value. Should I write it right out? 4 times 4.9 times 400. It's 78.4. This is actually plus, right?
Yeah.
Negative, negative. So 78.40. I'm probably writing out more than I need to. I won't, thank you. 88.9, that seems like a familiar number to me. 88.9 all over minus 9.8. Oh. Let's just pause here for a second while I clean up my messy handwriting. Okay, you've done a lot of work up to there. Can we reduce the amount of work? It says minus 8 plus or minus. Do I have to do both?
Do the plus.
Why do the plus?
I forget.
What's that? Time can't be negative, but you will notice that the bottom is negative, so the only way to make time positive, the whole thing to be positive, the only way to make the whole thing to be positive is if I do the subtract.
No! The reflex, Steve. Thank you, but I don't.
So minus 8 minus 88.9, right?
You can't even do it.
It was a little bird-like, wasn't it?
You really shouldn't. You can't do it near as cool. I don't understand.
Got me there.
I get 9.9 seconds. 9.887. Hey, is that the same number as this?
No.
It is.
Who would have thought?
9.89 and, okay. You know what? I'm going to do this then, and I'm just going to write what my calculator says. It says 9.887.
Well, they still have the same number.
Quinn, don't make me come over there. So you could either do 1, 2, 3, add on, 4, 5 steps to get to 9.89, or you could do, well,
Well, it's like.
it's one big giant, yeah. But it makes you feel like, man, am I smart, I can do this. That's the way I feel. I'm like, I am like in the top 10% of the population. I know what's going on there and I can do that and I feel good about myself. Sounds like a what?
Basically put an equation. You can do it the other way.
Whatever way you prefer, I don't care, but I like this way. I'm not going to judge you if you choose to do it this way. Well, I will, but it'll be silent. I won't let you know the result of my judging. Okay, so that's the total time. What else do we have left to do? The range. Is this easy? It actually is. And this is the only time that you use the horizontal velocity. And I'm writing that to remind you. The only one that uses the horizontal velocity is the horizontal range. Everything else was vertical. Is there an acceleration horizontally? Here's the classic mistake that everybody makes. Don't write this down. People write this. They go D equals, they give the vertical, the initial component, it's 6. They get that right. They do the right time, 9.89. And then they do this, 1/2 minus 9.8 times 9.89 squared. What mistake have I made? Don't write this down.
That's not right acceleration.
You're right. This is a horizontal speed. This is a vertical acceleration, and you cannot mix them. They are like oil and water, or whatever other things you shouldn't mix. Toilet bowl cleaner and,
Drugs and alcohol.
sure, texting and driving, bleach, thank you. Do not do that. I will judge you if you do that. Yes. And on paper. Do not mix horizontal and vertical. So what do I do? Well, you could put 0 in there if you wanted, but what would that make all this? 0. So all you really got to do is D equals V times T, which is like one that you did like back in grade 8 or 9.
I never know when to use it or not, though.
Is the velocity constant?
Oh, geez.
Horizontally?
Yeah.
I got you, didn't I?
You can't do it right, don't do it at all, Jamie.
So 6 times 9.89. Oh my goodness, that's a big number. 6 times 59.3 meters. That was a lot of work, wasn't it? In fact, that took like a half an hour to do. It better take you a lot less time to do it on a test.
But there's no other part to it.
There is, you're right. What is that next part?
I don't know. I'm still writing down this one.
Velocity
Back it
impact.
up, back it up. Thank you.
How do I find the velocity impact? Same way we've always done. Take the horizontal, which is 6, and take the vertical. Do I know the vertical? Is it 8?
No.
No, it was 8 originally. Now what is it? No, it's VI plus AT
Why has it changed?
because of the acceleration. Because of gravity, right? The vertical speed is changing because of acceleration. So that's going to be our 8 plus minus 9.8 times our time, which was 9.89. So it's going to be 8. Now, is it important that the 8 is positive and the 9.8 is negative?
Yeah.
Oh, yeah. Because they're going in opposite directions. I get minus 775.
Is that the right time to use those?
Ah, very good question. Excellent question, Jason. You don't think it is?
0.9 or 0.4?
The 9, he's concerned we're using the 9.89 seconds. He's thinking we should only use the 9.07, the falling, right? Because I used positive 8, that's the initial velocity at the start of the entire trip, and the entire trip takes 9.89. So this is saying, give me the final velocity when I launch it straight up at 8, and it's accelerating at minus 9.8 for 9.89 seconds. So this becomes a large negative number, right? And then this is the positive 8. So it's 8 up, but it goes down to 0, and then it comes back down. So yes, that is correct. You could, if you want, Jason, you could start your VI at 0, and then you would use the 9 point, what was it? Just the falling, right? You could use the 9.07 if you wanted, and it would give you the same thing.
But if you did it the high society way,
You'd never have that exactly. Bingo. And in fact, this is sort of the high society way too, right? It's just easier high society. Yeah. Same idea. So yes, good question. You're just wrong, but great question. 775.4. That seems a little large, yeah.
That is very.
That is large. 8.
77.54.
Yeah, let me just do that again here. 8 plus 9.8. My calculator skills are waning.
I got like 88.8.
Yeah, that seems more like 88.9. Thank you, Ryan. Yeah. Too many chocolate eggs. Or not enough, yes. Thank you, Ryan. So now what do? you do that whole v squared equals 6 squared plus 88.9 squared. You guys have done this 1,000 times. Because we're finding this velocity here at impact, right?
Well, what did we just find?
That was just the vertical component. So I'm going to square that number, add it to 6 squared, and I'm going to try not to remember to square root it. And I get 89.1, which isn't too surprising. And of course, you got to find an angle there.
Oh my God.
Oh yeah. If you can do this question, this is it. Like you've learned enough. I should give you, if you can do this question, I should just give you the credit. Automatically get the credit.
Yeah, this is definitely it.
That's pretty much what it boils down to. Now, having said that, if you can't do this, well,
Pretty much not gonna get.
Well,
so therefore I can't do the one with it. Yeah, so it doesn't really work. The angle. Because it asks for velocity, and that's a vector. (86 degrees). 86 BTH, below the horizon. That is a huge question.
would you lose marks if you didn't do that BTH?
It depends on how generous I was doing.
Like, I would never know when to put, because when you went into direction, you put like...
If the question had north and east and south and all that, right, then you have to include that. But it doesn't include it here.
So you would always say below?
In projectile questions, it's generally going to be BTH and yes, generally. Okay?
So this type of question, like, kind of screw up in one spot. Like,
Oh, I will follow it through absolutely, Steve, right? But here's where that organization and showing your work and writing the form and all that stuff is so important. So that because yeah, it takes a long time to mark. Yeah, Ryan.
So, speaking about like below the horizontal, say you were like on the ground and shooting something.
That's above the horizontal.
Onto the cliff?
Yeah, still ATH. Yeah, yeah.
And would you do the sort of same steps for that?
Yeah, you're asking if the question was sort of reversed instead of shooting off a cliff. If you do that, right? Yeah, absolutely. The only difference would be instead, in the elegant, sophisticated, snobby way, instead of being minus 400 here, it'd be plus 400, right? Other than that, it'd be exactly equal. I like that. I should change the question to do that.
Oh, you shouldn't.
Why not?
It's put me off my game.
It's a novel situation. Okay, so now I think what I've got here, yeah, this is that flat side one that I'm going to do another day. I think that I should probably get you to do one.
all right.
Okay, why don't you try this one on your own?
That's actually...
Yes, I know, but the only way to get good at it is to practice it, right? So this is exactly the same. The only difference here is now it's 20-degree ramp.
And skier.
It's a skier. The ramp is 50 meters high, and the Olympic standard is 75 meters. Now, it's sort of a crazy kind of thing. It's not, you know how the ski jump, it's like you land on a hill, right? They don't have you land on the flat. That'd be a little dangerous. But we're going to make it easy. So how far away, basically, have they got to 75 meters or not? Okay, so what do we got here? Can you tell me the VV and the VH quickly?
VV is 6.15, and VH is 16.91.
Does everyone agree?
Yep.
Okay, so elegant way, D equals VIT plus 1/2 AT squared. So that's going to be minus 50 is equal to 6.15 T plus 1/2 of minus 9.8 T squared, right? 0 is equal to minus 4.9 T squared plus 6.15 T plus 50. If I just ask someone for the answer, will we trust them? What is it? 65 seconds?
Well, that's fine.
I want you to do the quadratic.
But
You want me to do it out?
3.9 seconds.
That's over the edge.
Minus b plus or minus.
We don't.
That's what I thought.
Okay, my only question is actually, which one do you pick there? Do you pick minus? Because I thought before.
You pick
Oh.
2 minus.
Okay, I'll go through it. Yep.
Alright, yeah.
In all of these questions, 2a, is it always going to be 2 times minus 4.9? Always, because a is always going to be that 1/2 minus 9.8, right? This is always going to be minus 9.8.
So you just pick the one.
So you will pick the one on the top that makes a negative.
Okay, that's what I think.
6.15 plus or minus the square root of, which is always going to be positive, right? Regardless of what it is. So that's going to be b squared 6.15
Is there any way
squared.
that the thing in like the square root, like you might have to pick positive?
Yes, it could be.
Because like say like the 50 meters, it's like a 0.5.
I suppose, yeah, it's possible, right? This would have to be very large negative, right? This 6.15, and that comes, no, it's not. It's always going to be negative, isn't it? Because this is always going to be positive, this 6.15. So this is always going to be positive. So the only way for it to be negative is to subtract. So it's always going to be subtract, isn't it? I never realized that before.
So just pick the one that makes it time positive.
Yep, pick the one that makes time positive. 65 point something, Steve?
5.5. That's not T, that's final.
That's the meters, yeah.
So he's got.
Do you want me to keep going here? I'll do this because I got time, because some people might want to see it. If you don't want to watch, that's fine. I've got time to finish it. So this is going to be b squared 6.15 squared minus 4 times a times c .15 squared minus 4 times 4.9 negative times 50. Did you guys get 31.9 there? Did I do that right? Did you get 31.9 there? Someone please? Anyone? 31.9? So that's going to be 6.15 minus 31.9, and then divide that by negative 9.8. 2.63 seconds. And then v equals d over t. The horizontal velocity was way back at the start, 16.91. Ooh, is it even 65? I got 44 meters. What did I do wrong?
I went different seconds.
You don't have 2.63?
I was 3.88.
Okay, let me go back and do that again.
Did you miss the square root?
No, I don't think so. Oh, maybe, no, because that's the giant number there. 6.15 minus,
I think wrong, because yours looks the exact same right up to 2.63 is what I did. I think just your division there was wrong.
I did it again and I got the same thing. What are your numbers?
Same as yours.
Exactly as this? Like almost?
I'm pretty sure.
6 point, oh, is it minus 6.15? Yeah, that's why. Sorry. It's minus.
That's a half mark deduction right there.
Shame on me. Shame on me.
I'm selecting when I'm wrong, or when I'm ranking wrong.
Just
What I look for.
go ahead and say, Mr. Bennett, you should organize your work better.
It doesn't matter to me. As long as it's okay, as long as you get the right answer, I mean.
Yeah. 3.89 seconds. Does that sound better?
Yes.
You had to get
75 meters. You actually do that? What, it can't even fall? What?
65.8 meters, so the answer is no, right? Okay. What do you think, Manny? Okay? Elegant way or the other way? Haven't decided yet? Doesn't matter? Okay.